It's my pleasure now to introduce Andreas Blumauer, and Andreas is the CEO of Semantic Web Company. So Andreas, take it away.
All right. So, yeah, welcome to my talk about recommender systems. My passion has always been around graphs, and as we've heard, the fusion with machine learning brings us to the next level. And this is what I'm going to talk about here. Recommender systems are pretty much the most advanced, let's say, search applications on top of all what you've seen in the talks before. So we start with taxonomies, and then later on you start using some machine learning algorithms. There's a search somewhere in the architecture, and on top of all that, recommender systems will play a very important role in your information architecture. And I'm hopefully will be able to tell you why it is so important. You know, we are the whole day confronted with a lot of questions. Where are the go-to persons at this conference, for instance? So I have very specific reasons that I'm at the conference. I have very specific topics to solve in my everyday working life and also private life. We have a lot of questions and there are lots of answers. So we need to connect them, but how can that be made possible? So this is a little example of all the questions probably which are around here. The blue ones, by the way, I try to address a little bit in my very short talk here. So lots of different questions, and the really sophisticated problem here is it's about a combination of questions on the one side, your intent, your context, you have a role in your company, and on the other side, there are lots of people around who may have an answer to your question, but where are they? Where are the presentations I should go to, et cetera, et cetera. So recommender systems are all around. Also, even if you ask where can I get a good coffee in DC, you may not find the right person, or you may. Well, what we all know is recommender systems like that. We know that from e-commerce. And I'm not trying to convince you using such recommender systems for knowledge management, because that's a different story. Because those recommender systems, as we all know, tend to just produce more of the same. So if you buy an SD card, next time you come to your e-commerce platform, you will probably get another recommendation to buy another SD card. That's not very smart. It should be rather like that. I just went to New York City last week. It was a great trip. I bought a little bridge camera just to make sure I really have nice photos afterwards. And if the recommender systems would have recommended me, for instance, where the places to go to have really good views on the attractions, or after having bought the camera, you should buy an SD card, that's much smarter. Such recommendation systems I would expect on my digital workplace. So I wouldn't resign, for instance, probably. That's one of the things I would expect. So it's no longer collaborative filtering, which you see on the left side. This is good for e-commerce. It works pretty well if you have a lot of users, like millions of users. So you can use their behavior patterns to do recommendations. But this is not the case, not even at Siemens. Because at Siemens, there are lots of people working on very specific topics. So you need a different architecture for your recommender systems, which are the so-called knowledge-based recommenders. And my strong belief is that such enterprise recommender systems will dramatically change the way we are going to work. What Sinequa has just presented is one example how that could look like. How the architecture behind that really looks, that's a different question. And here, as an architect, you have to be very careful to select the right strategy. And also very important to see is recommender is built on top of all this infrastructure. So when you're starting out with semantic search, that's the first step typically. Next step probably would be to have even better insights in your data by, for instance, linking data, having nice dashboards on top. So really search-driven applications are what's called insights. And on pretty much the same architecture and infrastructure, plus the knowledge models in place, you can build the knowledge-based recommender systems, which then build or create the basis for smart applications, for augmented intelligence, like self-servicing portals, smart assistants, next best actions, for instance. So what is that exactly? It's always the same principle. You have a lot of people in your organization and maybe customers, partners. They have a semantic profile. That's on the bottom right. Then you have, of course, a lot of information around, and the user has an intent, has a question. There's probably also some structured data in place. So and you want to link all that. That's basically what a recommender does. It brings the assets, the knowledge objects, next to the people. And where could that be helpful? For instance, truck approval. That's a great example where a business-critical process of an enterprise can benefit the people who are working on the truck approval process. So you find the right people who have worked on similar stuff before. You find similar questions other colleagues had in other occasions before. You don't want to contradict yourself in front of the agencies when you submit the truck. So obviously this is something very powerful, and those kind of recommender systems cannot work based on a collaborative filtering. That's not, the data is just not in place. Not even the large pharma companies would have that. You need a knowledge-based recommendation service. Try it out, please. We at Pool Party, we have built such systems for many years. It's built on top of our knowledge graphs, on top of our machine learning and artificial intelligence, and it produces those results. There's the HR recommender, for instance, as an example, on the web. Play around, feel free to use that, or we can also give you, of course, a demo at our booth. So what makes recommendations really helpful? What's the problem behind that as well? It's all about your role, your specific role in your company. There are lots of other people having produced a lot of content, like, for instance, support desk, documentation, marketing, legal. They produce a lot of knowledge. But what is the right information for me? So the customer here is quite frustrated because his role probably is not clearly built into the system. So he's overwhelmed with information. You need to personalize the information or the results of your recommender system. And that only can work with this architecture you here have in front of you at the moment. So this person has an intent, has a context, and only that in combination can bring the user to the right content. That's kind of this triangle you should remind. But this is not enough. And now we come to the last point. In order to combine those three dots in this triangle in a way that it really brings the right recommendations next to the people, you need to solve a combinatorial problem. It's no longer search. And how does the system know what things should be combined? This is the magic question, really. That's what we have been discussed here in this community for many, many years. And it's the domain knowledge model. You cannot solve that with machine learning only. This is not possible. Your domains are too sophisticated typically. And in the domain knowledge model, you encode kind of rules which content fits into the picture when a certain context and a certain user intent is given. This is actually how the model looks like. And how you can solve that now, I'll come to a little example. Let's say that person, Ashok is his name, has a couple of context information around, like for instance, he's gluten intolerant. Okay, what does that mean? If Ashok is going to buy something or he wants to know something about bread baking, it doesn't really matter if he's gluten intolerant. If he wants to know it, fine, he still can read the history of bread baking about wheat-based bread. But if he wants to bake bread and wants to have recipes, of course he doesn't want to have recipes he couldn't use as a gluten-intolerant person. This has to be said somewhere. It has to be set as a rule. And these kind of rules you can model within your taxonomies and ontologies. This is going to drive the precision of the recommendations later on. A Shock doesn't want to have recipes where wheat is included. He wants to have those where brown rice probably is the basis for his bread. So how to get there? It's kind of a crawl, walk, run, fly modus. We've seen that frequently with our customers. Everybody wants to have a knowledge graph. Everybody wants to have Enterprise 360. Well, that's the fly status. But you have to get there. So you have to start somewhere. And content types and structure, like for instance, component content management systems provide a great basis for such information. On top of that, taxonomies, ontologies bring in all this information in a right structure so that you can then later on really walk, and with recommender systems already, you will run. So this is definitely where management already is seeing clearly, oh, there's a lot of benefit and business value with the walk status and the crawl. You have to get over that as quickly as possible, maybe with little prototypes, first of all. And this is where how you can get step by step to this status. Well, to sum up, enterprise recommender systems are not the same as e-commerce recommender systems. They work differently. They're based on your search infrastructure. You're going to use knowledge models to make that work. It will bring a lot of value in terms of better knowledge discovery, better product understanding, better decisions in general, and obviously this translates into better employee satisfaction, no resignation anymore, better user satisfaction, obviously higher sales. If you want to know more, please drop by the pool party booth at 201. Hope to see you there and enjoy the conference. Thanks a lot.